How do contaminants spread in groundwater? Imagine water moving underground like a slow-moving river, carrying with it tiny particles and chemicals. That's how contaminants can travel through the ground. When water flows through soil and rock, it drags dissolved pollutants along with it. This process is called advection. Think of it as a conveyor belt moving contaminants from one place to another. The faster the groundwater flows, the quicker the pollutants can spread. But groundwater doesn't move in a straight line. It flows through a maze of pores and channels that vary in size and speed. This causes the contaminant plume to spread out, a process known as dispersion. It makes the pollution wider and less concentrated as it moves. Contaminants can also spread by diffusion. This is when chemicals move from areas of high concentration to low concentration, even if the water isn't flowing. Over time, this causes pollutants to slowly seep into nearby soil or rock layers. Sometimes, contaminants enter low-permeability zones like clay or rock. These areas act like sponges, absorbing pollutants through a process called matrix diffusion. This can keep contamination alive longer because pollutants slowly leach back into the groundwater even after the main source is gone. Chemical interactions also play a role. Some contaminants stick to soil or rock surfaces, a process called sorption. This slows their movement because they are temporarily attached to the material. The amount of sorption depends on the type of contaminant and the soil's makeup, especially organic carbon content. The geology and hydrology of an area influence how fast and for contaminants spread. Porous aquifers allow easier movement, while layers of clay or rock can block or slow the flow. Fractures or poorly sealed wells can create shortcuts for pollutants to bypass natural barriers. Human activities like pumping water from wells can change flow patterns. This can pull contaminants toward water supplies or spread pollution over larger areas. The depth of the water table also matters. When the water table is shallow, contaminants can more easily reach the surface or nearby buildings. This increases the risk of exposure through vapor intrusion or surface water contamination. Knowing how contaminants move helps us protect groundwater resources. Monitoring flow patterns, soil types, and pollutant behavior allows us to predict where pollution might go and how to stop it. Proper management and cleanup depend on understanding these natural processes.